Hello and welcome to my presentation about the Matrix game. My name is Will. I'll be talking about the game that I've made and a few different ways to play it. Before we get started, I'd like to play a simple version of the game. The rules are we take turns picking either the first or last number in this list. The person with the most points at the end wins. So I'm going to pick this 9. Now your options are the 6 and the 7. But before you get your hopes up, let me stop you. The game's not, it's actually fake. Uh, so, this is the same list of numbers, but I've colored them this time. When I pick this 9, your options are 6 and 7, which are both blue. No matter what you pick, I'll have a red and a blue option. So if you pick the 6, I'll have a 2 and a 7, which means if I pick the red 2 again, you'll have only blue options. So what's happening is I get to add up, if I'm player 1, I get to add up these, like every other value here. So I can add up the red ones, and then I can add up the blue ones. And I see that the red ones are 29, and the blue ones are 23. So I just pick the red values. I get 29 points, and you get 23 points. So I call this a controllable outcome. I don't know if that's the proper term, but the first player just gets to pick if they want to win the game, basically. The worst that they could do is tie if they're playing by this method. So the Matrix game is a more complex version of the same game. There are 4 options instead of 2, so that player 1 doesn't just get to choose if they win or lose. Anyway, this game plays very differently from the first one. The options iterate in different ways. Let me just demonstrate this really quick. So A progresses. This is the same board. A progresses like like you're reading a book. So it goes from left to right and then resets at the end of the line. Option B, I'm just clicking the same ones over and over again, goes down and then resets when you reach the end of that column. Option C goes to the left and then resets upwards when you reach the end of that row. And then option D is just the opposite of B. It goes up and resets. So the way that I look at this is that option A is like reading a book. If I flip this 90 degrees, option B is like reading a book. If I flip this 90 degrees again, option C is like reading a book. And then if I flip it one more time, option D is like reading a book. So let me just reset this. Here we go. All right. So these options, this is not exactly the way that I did it in my final program, but this is some pseudocode. A is, this is how A works. It just iterates through the array in the most normal way that you can think of. It just goes straight through, adding 1 every time, or adding 1 to the column every time, and then reset. Anyway, C is just the opposite of A, and then D is just the opposite of B. You can pause the video here if you want to look into this a little more. But that is the code here. And when I say the opposite, I mean that if you stored all of the value, or like all of the elements in order for A, then the opposite of that, like the opposite order of that list would be C. And same for B. If you stored all of the elements in order, the way they would appear in B, then D would be just the opposite of that list. So the next thing that I want to talk about is the minimax algorithm and the greedy algorithm. The greedy algorithm just picks the highest number available to it every time. So for example, in this, if the greedy algorithm was going first here, it would pick the 9, just because it's the largest number available to it. Anyway, but I want to talk about the minimax algorithm more because it's a little bit more complex. So the minimax stands for minimize maximize, which is understandable. So we're minimizing here on this red row, and we're maximizing here on this blue row. So this thing is pointing upwards because we're maximizing, and these red ones are pointing downwards because we're minimizing. So as we see here, the blue one is choosing from these red ones. This red one, let me step into the red ones first. So what we're looking at is, this is option A, this is option B. So we're considering what our opponent can do if we pick option A. So we get 9 points for picking A. And then we want to look at what our opponent can do. So he can pick 1 after, that's because A moves there. He can pick 2, which is where B is, 2, which is where C is, and then 6, which is where D is. So this is 1, 2, 2, 6. Assuming our opponent picks the largest number available to it, then it will pick this 6, and we get this 3 by subtracting 6 from 9. Because what our opponent is doing in these red ones is he wants to minimize this number. So the way to minimize it is to pick the largest of these numbers. So 9 minus 6 is 3, which is how we get that. By the same logic, this is for option B. So if we pick B, then our opponent's options are this A, the 9, B is 1, C is 2, and D is 6. 2, our opponent's going to maximize this number, so it's going to pick 9. So then we say 2 minus 9 is negative 7, which is the lowest this can get, so it's minimized. Same with C here, that's also going to be negative 7. And then D, 6 minus 9 is negative 3, which is the largest. So the closest one to that is negative 2 here. Anyway, we're still going to pick the first one because it's the largest of these 4 values, because we're maximizing this value. That's how that works. So you may be thinking, if the Minimax algorithm is picking the best move every single turn, why doesn't it always win? And there are a couple reasons for this. One is that the game is very luck-based, with 10 different, is it 10? I think it's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. No, it's 9, sorry. I should know this by now. Anyway, so there's 9 possible options for each element in the array, and a 9 is a very high value and a 1 is very low value. So having a turn 1 9 is very important, and then giving your opponent a 1 is also very important. So turn 1 9s are very, it swings the game in player 1's favor. So my goal was to make it to where player 1 couldn't just choose to win the game, and he can't do that, so I've achieved that goal. But he still gets, if there's a 9 or a very high value in the opening 4 options, then he has a big advantage. So, but there's luck in most games, so I think I can accept that. Something I could do would be to increase the size of the board, or to lower the range of options. So these would be something like 1 to 5 or 1 to 7 instead of 1 through 9. I could do that. That would lower the amount of luck involved in the game. But right now that's not really what I'm focused on. I've accomplished my goal in making a game that is not predictable from the first turn. And that's all I have. Thank you for tuning into my presentation. I hope to expand this project either by making it an online browser-based game or a mobile app that you can play with friends against the algorithms or against online players. I also hope that this project gets more people involved with coding and computer science. And thank you for listening. Stay safe, everyone. Have a nice day.